Hey everyone, in this video I want to show you how to graph a watermelon slice on Desmos. We're going to start with the base shape of it, which is just the triangle slice. And we're going to be organized by putting everything into... You can choose to make folders, or you can do what I'm doing, which is just making comments. So for triangle slice, I'm going to go with an absolute value of x. I'm going to move it up by, let's move it by 6 units, and then we'll compress it in by a little bit. And for the bottom piece, that's the skin. And so for that, I'm going to use 2 ellipses since there's a thickness. That's going to be, put a y equals for good practice. We want the bottom half of the ellipses, so I'm going to do minus the square root of 1 minus x squared. I'm going to divide it by some number here. Make it wide enough. I'm going to duplicate this. And this is going to be how thick we want this skin to be. And maybe we'll make this a little more round. So let's make this 1.1 maybe. That seems a bit too gentle of 1. And this we should make this a little wider. Now, I would like to be a little more organized than this, since the point of this is to lay out a strategy on how we're planning on making this slice. Realistically, if you were to look at a watermelon slice, this outer edge here scales evenly with this inner edge here, and so what I would like to do is just start with the base shape of what we want the inner edge to look like, and that'll decide what kind of shape the outside is going to look like. Here's what I mean by that. Let's graph an ellipse. And this is going to be the inner ellipse that are going to be going from. And so we'll mix some variables. Let's call this, I know books call them A and B for the horizontal and vertical scales. And so I'm going to call this one I would like the 2 numbers to be different so that you can see how we're planning to use them. So this would be a squared, and this would be b squared. And I would like for this to be the overall scale. And so let's make a 1.5 so you can see something happen to the outer ellipse. So if this is what this is going to be, all right, let's make this blue. And in fact, if this is one, I'm inclined to call this s squared. So if you divide this across to get this 1 back, you'll be getting s times a the whole thing squared, s times b the whole thing squared. And so that's why I've deemed it more fit to put it on the right side rather than scaling each of these individually. So now you can see here that this is really the skin thickness. Let's flow these two back down here so you can see what we're really working with. And this is really, let's disable these two. Let's bring this one back, disabling the absolute value equation. This is really all right. Let's solve for y on the fly here. This is 1 minus x squared over a squared, and then we need to multiply b squared across and take the square root of it. So this is, am I going crazy? 1 minus a squared x squared over a squared, and then you multiply this by b squared. So this is, so before you even take the square root of it, you should be multiplying this by b squared, aka this in front is just b squared. Okay. And we do the same thing. We do the same kind of math here. So this isn't 1, this is s squared. This is still b. And we don't need the minus 1 anymore. And this is also b squared. What am I doing? This is a squared. And now you can adjust how wide you want this to be. And you can have this decide how you want your triangles to how you want your triangle to be drawn. So now we can bring this back. Right, now I like to define some variables to control the height of this triangle piece here. And so we're going to have one for the height. So that's going to be 6, and that's going to be going into this one here. And this is the compression factor. So I'm going to call it K, as confusing as this is going to look, because as H and K are often used for vertical and horizontal transformations. But we only have 26 letters in the alphabet, and unless we go for subscripting, this is what I'm choosing to do. And so if you have different names that you prefer, it will not offend me one bit. All right, so I was not expecting to spend this much time on 3 seemingly simple equations, but now we can find the intersections. And as much as I would like to steal these numbers that are looking at by hovering them, I think since we're already going down the path of dynamically drawing the shape, I would like to calculate the exact values of these points. Let's start by trying to find the exact point of this one, and to started calculating the intersection, we need to decompose this line into two equations. And so what this really is here is y equals kx plus h, and we also have minus kx plus h. And so if we want this left intersection here, we have this linear equation here with this value here, and this is obviously a lot easier than taking this absolute value with us. And so we're going to do on the fly math here. So this is we want to find an x such that the kx plus h here is equal to this value here. So let's put this down here. Now we're going to solve for x in this equation here, and I did some thinking, and even though normally I would just jump to show you what the answer is, I think it'd be beneficial for the larger audience to see how this is done. And so it's a bit of a process, and so please do bear with me on this, since I do think you're going to benefit from this. First step, I would like to isolate this square root here, and so that's why I divided it by minus b. And then we're going to square both sides so that it would expose this inner term. All right, so when we do square it, we lose the square root on the left side, obviously. This minus goes away, and we square the top, and we square the bottom here. Notice that an extra line did appear, and that's because when we take a square root, we do get two solutions in most cases, and so that's why this second solution, the one that we weren't actually pursuing, did appear. That is okay. And now you can see that we have a quadratic term here, and once we do expand this will also be a quadratic term, and so eventually we'd be grouping them together, and so we will be looking at one big quadratic equation. Let's move this term to the other side. So we're going to add x squared over a squared. We would like a common denominator between the two so that we can add them together. And so this becomes, so we multiply a squared over here. And then we multiply b squared over b squared. Now would be a good time to expand this term here. So this would give us, in fact, so that we have the two terms in front of us. So first term, this is the binomial expansion theorem. So it's the first term squared plus 2 times k times x times h plus h squared, and now we distribute the a squared across the board, so that gives us 2a squared. these are all constants, and so that's why I don't really care which um, where it ends up, because this will all evaluate to one number, one single constant. So this is okay. And now we can add this term. This is a squared plus b squared. All right, because combine like terms. And now we don't need this piece anymore. Top 10 reasons to not skip steps. So we're gonna add this, and so we remove this. That should be unaffected. Okay, good. And so now we know that this evaluates to a constant, and we want to add this b squared term. Now I should get a better looking result. There we go. All right, now we subtract 1 onto the other side, and this would mean subtracting a squared times b squared on the numerator. Let's just move this upstairs. Now we can apply the quadratic formula, and when we do this, we need to be mindful that there's extra scale down here. So as tempting as it is to just take this top piece here, we need to always bring this bottom piece with us. I'm going to disable this, and then on the bottom here, this is where we get to apply the quadratic formula. So that's negative. What is our b term? That is this one here. Remember, we always want to carry the denominator with us, since everybody's being scaled by this term. I'm going to start with the plus solution first. And we need to square this piece. Well, just b squared, so we can let's grab this 4 times. Let's put a multiplication dot. Make sure that we're always carrying this denominator. And then our c term is this whole thing here. If you're wondering if we're going to simplify this, yes, we absolutely are. Because I would like to not have to deal with all this either. Let's put a multiplication dot so we know what we're doing. So our c term is this. A multiplication dot is outside the square root. Be careful. And it's going to be all this. Control A will select everything. Control A, hit the division. And it's 2 times Actually, our A term is right here, so we just steal this guy here. And then our minus solution, I'm doing this just to sanity check my math. And let's put an x equals in front. All right. So evidently, it's this black line here that we want to simplify. And so I don't want to see this purple line ever again. And neither do I want to deal with this. And so let's simplify this. And I want to be staring at this black line so I know we're all looking at the same number. All right. So first off, this a squared we can divide that out. All right, this one we can't factor immediately. This one I'd like to keep as is. All right, this square term here is, let me move this up here so that you guys see what we're trying to expand. This is 4kh 8 squared over b to the fourth. This one I'm going to expand this out, and I believe these two we can actually, before we multiply across, we can factor out this a squared. So we can delete one of, actually we'll just delete two of each. And then now I think we can safely multiply them across. So if we multiply this b squared across, I think this gets us a b to the fourth. Let's put these in parentheses. And let's put this in parentheses. This is not as simplified as I was hoping, though. Let's see. We can factor out the 4, and so if we factor out the 4 here and take the square root, that gets us a 2 in the front. So let's do that. Just thinking twice to make sure I'm not going nuts. All right. And so now that we have a 2 in front, we can divide out the 2's. Now, before I call it quits here, is there anything else that we can simplify? And I suppose we can do a bit of cleanup on the parentheses. This I'll keep as is, because if we multiply this out, this would be too giant of an equation. So I'm going to leave this as is. I will leave this up here so that you know where it all came from. And I'm going to save this to a variable because I would like to not go through the same motions. And so something I think might be slightly better. Oh, never mind. Forget I. So it multiplies across by -1. I think that gets us, makes this negative, makes this positive. There we go. So what that has done it gave us the intersecting point on the other side. All right, now we can bring back this equation and let's use, so let's define the boundaries for this one. So this would be, we move this up to here. I'm gonna move this up. Okay, this is a little more organized, and this is going to go from -x0 to +x0. And I will not hesitate to... Actually, this boundary is for the bottom equation here, which we'll use the same process for. I'm not going to do this one on camera. Instead, I'm just going to do it off screen and come back to you with what the result is. All right, I got x1 calculated. So you can see it's really just a difference in have an extra s squared in the c side, and what that has allowed us to do is, like, I know it's a bit of an overkill solution for a simple watermelon slice, you know, but what you can do now is you can use these sliders to adjust the shape dynamically. Now let's color this thing since we put in so much work for this. So we'll start with this top equation here. So we'll go, actually let's make this is the base shape, and since we're using folders, let's make a folder. I'll put this inside. This is the top equation, and then we want the bottom one here. And this spans between the smaller x boundaries. And for the absolute value equation, this is also the top boundary for what we need next. So this is top here. This is the bottom. And this is going to go from x1 up to x0. And then we go from x0 up to the x1. And for this red piece here, in fact, let's make this red. We'll grab this one. And we want everything on this one because it's the boundaries we also care about. And depending on where you want your green line, if you want it to be or over on the top, then this goes in order. So in this case, I chose to put the red piece first, and I put the green piece on top of it. So this I will make available in the description for you to check out. It's got sliders for you to play with, and if you want to see a part 2 where we add the seeds onto this, so it'll be the same graph. So this link here, this graph ID, I'll put it in the description so you can play the sliders, and you can see the original equation that we came from. Other than that, well, I hope you gained something from this. If you felt like you did benefit, do leave a like. If you did not, well, first off, sorry to hear that, and let me know in the comments what you felt would have been helpful. And if you want to see more videos like this, do subscribe, and I will see you in the next video. Thanks for watching.